Welcome to this video on rational and irrational numbers. Let's begin. This video will attempt to answer the following questions. What is a rational number? What are equivalent fractions? What is an improper fraction? And what is a mixed number? Let's begin. In a previous video, we defined natural numbers, whole numbers, and integers. To define them, we just expressed them as a set of numbers. We didn't give a word definition. So remember, natural numbers are also called counting numbers. They are 1, 2, 3, up to infinity. Okay, so remember, natural numbers is the most specific group, and we said that all natural numbers are whole numbers. Whole numbers are all natural numbers as well as the number 0. Then we defined integers. Integers are all whole numbers, but again, they can be positive, negative, or 0. So integers span from negative to positive infinity. There is no lower or upper limit on the set of all integers. So this is really important because we need to know and understand what an integer is, because we're going to use that word integer to define rational numbers. So what is a rational number? A rational number is any number that can be expressed as the ratio of two integers. So notice the word rational has the word ratio in it, right? And what is a ratio? Well, ratio is just another word for a fraction, right? It's the proportion. It's a ratio of two numbers, so that implies division. Okay, so in math speak, because math people are really lazy, so they created their whole set of symbols. So we would say A and B. The way we would read this is that A and B are both integers. So this cute little Z is represents the set of all integers. So again, as long as I can write a number as A divided by B, where A and B are both integers, then I'm good. However, notice there's one more requirement, right? Which is, and you might recall this from a previous video, we cannot divide by 0. So we put this extra caveat that B, our denominator, cannot be equal to 0. So that's what a rational number is. So let's talk a little bit more about rational numbers. An easy way to distinguish rational numbers from integers is that rational numbers can include fractions, as you can see, whereas integers do not. So you can see here, if we look at a number line, there are some values on the number line, right? For example, here, this is a rational number, but not an integer. This is also a rational number, this is a rational number, but they are not integers. Can you see any examples of numbers that are both rational numbers and integers? Notice that -3 is an integer, but it also can be expressed as a ratio of two integers. So, rational numbers are numbers that can be written as either a positive or a negative fraction or 0. Again, the numerator can be any integer you want to, however, the denominator cannot be 0. In other words, the numerator can be 0, but not the denominator. So this page kind of summarizes that idea. Again, if a fraction contains 0 in the numerator, then the fraction is a rational number. If a fraction contains 0 in the denominator, the fraction is not a rational number. In fact, it's not a number at all, it's just undefined. And if you watch my video on why we can't divide by 0, you understand numerically and graphically why we cannot divide by 0. So now we've defined rational numbers, let's talk about equivalent fractions. So equivalent fractions are fractions that reduce to the same fraction. So let's think about cooking, right? Let's say that I have, or baking. A recipe calls for half of a cup of flour, okay? But guess what? My half cup measure is dirty and is sticky with peanut butter, and I don't want to spend 5 minutes and get peanut butter all over my sponge while I'm washing it. So what I'm going to do instead of using my half cup measure is I'm going to use my quarter cup. So how many quarter cups of flour do I have to add to my recipe to equate to half a cup? Well, I would use 2 quarter cups of flour, because 2 over 4 is the same as 1/2. I can reduce 2 over 4 by dividing the numerator and the denominator both by 2, and I'm back to 1/2. So those are some examples of equivalent fractions. I could also say 5 over 10. 5 over 10 also reduces to 1/2. 3 over 6, right? 3 is half of 6, 5 is half of 10, so on and so forth. So that's what we mean by equivalent fractions. When I reduce them, I end up with the same fraction. Now, I have a question for you here. and this confuses many people. Most people get this answer wrong. So we have negative 2 divided by 3 in part A. In B, we have 2 divided by negative 3. And in C, we would read that as negative 2/3. So I want you to take a minute, pause this video and say, are these fractions the same? In other words, are they equivalent fractions or are they different? So pause the video, make a prediction, and then unpause it to see if you are correct. So the answer is they are actually equivalent fractions. They mean the same thing. So a silly little metaphor that I use to help you remember is think about a car. Right? I could park my car, let's say I have, I don't know, like a split level home where, I don't know, I can park in the front of my house and maybe there's a hill, right? My house is on a hill, or I could park, right? So here's my car right here on the top, okay? Or I could park around back, maybe that's down a level, right? Maybe, so I could put my car here, right? Or I could park my car outside, like on the street, right, outside of my house. It doesn't matter, right? There's still only one car. Okay, so these are actually all equivalent fractions. It doesn't matter whether the negative sign appears in a numerator, the denominator, or if it just appears outside of the whole entire fraction. They mean the same thing. So really quickly, what if I had something like this, negative 2 divided by negative 3? Well, the car metaphor kind of helps us here, right? Because in our previous equivalent fractions, right, I have one car here, one car here, one car here, right? Now all of a sudden, how many cars do we have? We have 2 cars. Can we agree that having one car and having 2 cars is not the same thing, right? It would be cool if you left your car alone long enough, it just sort of like multiplied and then you had 2 cars. That would be a great way to get rich quickly, right? But that doesn't happen. Okay, so this negative 2 over negative 3 is absolutely not equivalent to those other fractions. In fact, if you type this in your calculator and then it might give you a decimal, but either way, you find out that the negatives cancel out. A negative divided by a negative is a positive number. So these are equivalent fractions, right? Negative 2 divided by negative 3 is the same as positive 2 divided by positive 3. So those are equivalent to each other. Right? These 3 fractions are equivalent to each other, right? But the 2 boxes, they are not the same. They are not equivalent, okay? So be careful with your signs. Okay, so we have 2 more definitions to get through. The next one is an improper fraction. So quite simply, we still have a over b, right? Where a and b are any integer that we want them to be, but b can't be 0. Right? So we're still dealing with rational numbers, right? However, with an improper fraction, we have this additional constraint that the numerator a is larger than the denominator. Okay? So for example, let's say I gave you 1/2, I gave you, I don't know, 3/4, and I gave you 7/5. Which of those is the improper fraction? If you said 7/5, that's correct, right? 7/5 is an improper fraction because the numerator is larger than the denominator. The others are proper fractions, right? Because the numerator is smaller than the denominator. All right, the last definition that we have is a mixed number, and this is very much related to improper fractions. And in future videos, we will learn how to convert between mixed numbers and improper fractions. So a mixed number, you might recall, looks something kind of like this. So it has 2 parts, right? It has this integer, right? So that's the 1, and then it also has a fractional part. Okay, so that's what we mean when we say mixed number. And again, in a future video, we will learn to go from a mixed number to an improper fraction. And probably in elementary school or grade school sometime, you learned how to go from a mixed number, from a fraction to a mixed number as well. So we have a question, are decimals rational numbers? And the answer is kind of complicated because the answer is sometimes yes and sometimes no. So if you have terminating decimals, so in other words, let's say I have the decimal 2.414, right? So that's it, that's all there is to it, right? Can I convert that to a ratio of 2 integers? Well, I absolutely can, and if you watch my video on converting decimals to fractions, then you will absolutely know how to do that. Basically, it would be 2,414 divided by 1,000. So notice that 2,414 is an integer, 1,000 is an integer. The definition of a rational number is a ratio of 2 integers. Therefore, for any decimal that terminates, which is a fancy word for ends, meaning it doesn't go on and on and on forever, right, is an example of a rational number. Okay, so we've talked about terminating decimals. What about repeating decimals? So what that means is, for example, let's say you type in 1/3 into your calculator, right? It's going to look like something like this, 0.33333, right? There's only going to be a finite number of threes because, right, your calculator isn't infinitely large. Your display screen only has a certain number of digits to work with. You may recall that we can rewrite this as 0.3 with a bar over it. You might have seen that before. But the idea is that you have 333 going on forever. So again, if you have a pattern, right, so it doesn't end, but you can find a pattern here. For example, 1/3, the pattern is that it's just 33333 going on forever. Then again, that is an example of a rational number. Another example would be 1/7. You can type that in your calculator if you would like to. And when you do, you get something that maybe looks like this. So if you have this part here, you see it's 0.142857, okay? And then what's going to happen is it actually starts over. And of course, you would need like maybe a computer or something with many more decimal places to see that it just keeps going. So the pattern is 142857, 142857. Okay, so again, as long as you can find a pattern there, and that's what we mean by repeating, is that there's a pattern. It doesn't have to be the same number. It could be a series of numbers that repeat over and over and over again. That means that you're actually working with a rational number. So let's turn our attention to some examples of non-repeating, non-terminating decimals. So one example is the naturally occurring number pi. If you don't remember, pi is the ratio of a circle's circumference to its diameter. It's approximated, you probably know, as 3.14. But the truth is, there is no limit to pi. In fact, some people, when they're doing their graduate work, they try to keep finding, more and more digits of pi. That's a thing. Okay. Anytime you take the square root of something that is not a perfect square, for example, the square root of 2 is about 1.414, but again, this is going to go on and on forever, and even if you carried it out to 100 or 1,000 decimal places, you're never going to find a pattern there. Okay, so again, naturally occurring things like pi. You might have also heard of the number e. If not, if you keep going in your math career, you'll probably encounter it at some point. But again, it's sort of just a number that people have discovered, and it is also an irrational number. Okay. Notice that something like, for example, the square root of 4, that is not going to be irrational, right? Because the square root of 4 is just 2. So that would not be over here in the irrational numbers, right? That would be over here in the rational numbers. So again, the square root of 4 is 2. That is a rational number. So again, the answer to the question, are decimals rational numbers, is sometimes yes, sometimes no. If they end, or there is a pattern that you can find, then they are rational numbers. If they are non-repeating, non-terminating, or non-ending decimals, then that means they're irrational. Okay, so what we want to do in this next exercise is to practice identifying which numbers are rational numbers. So again, I invite you to remember the definition of a rational number, right, is some integer divided by another integer. Okay, and again, I invite you to remember that the denominator can be anything except for 0. We cannot divide by 0. Okay, so again, those two values can be anything you want as long as we're not dividing by 0. So please pause this video and go through and follow the directions. It says circle all the numbers that are rational numbers and put an X through all the numbers that are not rational numbers. Okay, after you've done that, then unpause the video and check if you were correct. All right, so I'm going to go ahead and start going through this. So first we have 3. So can I write 3 as a ratio of 2 integers? Well, absolutely. If I need to give it a denominator, I can write it as 3 over 1. Remember also, right, all integers are also, by definition, rational numbers. Right, remember this image, right? We have natural numbers, whole numbers, integers, and then on the very outside we have rational numbers. Okay, so if you have any integer, anything like that, right, negative, positive, or 0 value, and again, it's a whole number, it's not a fraction or decimal, it's still a rational number. So remember that. So we are going to circle 3, or 3 over 1, because it is a rational number. Okay, same thing with negative 15, right? We could make it as negative 15 over 1, right? So again, remember all integers, these are all integers, they are rational numbers. Okay, 15 over 9, this is a ratio of 2 integers. Okay, what about 4.512? So to figure this one out, we need to go back to this previous page, right? So is 4.512 a terminating or repeating decimal? Well, the answer is yes, right? It is a terminating decimal. In other words, it ends. It only has 3 digits. So yes. And again, if you forget, or if you want to watch that other video that I made, you could rewrite it as 4,512 over 1,000. So it is a rational number. How about negative 4 and 7/8? Well, this is what's called a mixed number. Mixed numbers can be and should be converted to improper fractions, and you can watch a video on that as well. Once you convert it to an improper fraction, of course, then it looks exactly like a rational number. It's a ratio of 2 integers. Okay, 0. 0 is an integer. We said all integers are rational numbers. Okay, negative 2/3 is a ratio of 2 integers. 5 and 2/3, that's another mixed number. Again, it's still a rational number. Square root of 2. So again, if we go back here, right, we said that square root of 2 is an example of an irrational number. Again, if you type it in your calculator, you'll see a bunch of digits. There will not be any pattern, and even if you had, if you want to use a computer that'll still show you like 20 or 30 digits after the decimal point, you'll see there is no pattern. So we're going to put an X over this. Okay, E. Again, this is another naturally occurring or discovered number, if you will. Again, this is an irrational number. Okay, square root of 16. Well, you can type that in your calculator if you'd like, but the square root of 16 is just 4. Okay, 4 is an integer, and remember all integers are rational numbers. Okay, so just because you see the square root sign doesn't mean you can automatically assume that you have an irrational number. You have to evaluate, or at least try to evaluate the root, maybe in a calculator, and then go from there. How about 3.141? Well, again, this fits that definition of a terminating decimal, right? So we have 3.141. We could express that as a ratio of 2 integers by writing it as 3,141 over 1,000. So again, this is a rational number because it's a ratio of 2 integers, so we would circle it. Okay, 7 over 0. Remember, our one restriction on our ratio is that we cannot divide by 0. So not only is this not a rational number, it's not even an irrational number, it's undefined. Okay, it's not a number at all. Okay, 15, so again, that's an integer, right? So by definition, 21.2, this is a terminating decimal, right? And again, if I wanted to write it as a fraction, right, I could write it as 212 over 10. Again, to learn how to do that, just to watch that video. Okay, pi, again, we mentioned that in this example here, right? Pi and e are two naturally occurring numbers that are non-repeating, non-terminating decimals, so they are irrational numbers. Okay, and lastly, 1 over 21, of course, 1 and 21 are both integers, so that is a ratio of 2 integers, and we're not dividing by 0. So hopefully at this point you have a clear understanding of what we mean when we say rational numbers, and you have floating around in your head at least a few examples, such as the square root of 2, e, and pi. You have examples in your head of non-repeating, non-terminating decimals.